Hello everyone, this is Electromagnetic Waves of Chapter 8, Class 12. The origin of electromagnetic waves is connected to the concept of displacement current. So, it's also important to study the displacement current. As we can see here, when a capacitor P and Q, this capacitor is P and this one is Q, is allowed to charge after connecting the circuit, the current flows through the connecting wires. As your capacitor charges, charge accumulate on the two plates of the capacitor, these two plates P and Q, and as a result changing electric field is produced. This is the electric field and there will be change in electric field between the capacitors. If we put a small compass needle between these capacitor, placed between the gap between the two plates of the capacitor, obviously it will shows little bit deflection here, and it shows deflection, and this deflection indicates the existence of magnetic field. The conducting current, this which is flows through this circuit, current connecting wires which is flowing through the circuit, cannot pass across the gap between the two plates of the capacitor. However, Maxwell assumed that flow of current across the gap between the capacitors, between these two plates, yes, it is capacitor, so as to explain the existence of magnetic field here. That is the magnetic field, yes, between these two plates. That's why when you put the magnetic needle, a small magnetic needle, it is showing the deflection between the two capacitor. Maxwell named it as displacement current and attributed its origin to varying current filled between the plates of the capacitor. Thus, according to the Maxwell, the varying electric field across the plates of the capacitor, yes, gives rise to magnetic field. Maxwell concepts of displacement current makes a continuous flow of current in such an electric circuit. Thus, according to Maxwell, the connecting wire, this is the connecting wire, the current flows through the connecting wire is the conduction current. Conduction current, which name is IC, and there is no displacement current. Through the gap across the plates of capacitor, this is the gap across the plate of capacitors, and there is flow of displacement current, which is ID, no conduction current, because this is not connecting directly by any wires. Now Ampere's circular law is completely modified. At first I am going to write Ampere's circular law, which is B dot dl, and for enclosed loop is equal to mu naught into I. For this concept, above concept, it is completely modified and it is changed like this: B dot dl, it is dot product of two vectors, which is equal to mu naught, and this time it is IC plus ID, where IC is the conduction current and ID is the displacement current. This whole formula in the box is called modified Ampere circuital law or Ampere-Maxwell circuital law. Now this formula is known as modified Ampere circuital law or Ampere-Maxwell circuital law, because this formula is the mix-up formula of a combination of Ampere law and the Maxwell law. The displacement current, I am talking about the displacement current. The displacement current arising due to varying electric field is given by ID, represented by ID, is equal to epsilon naught d phi, because it is due to vary in the flux, d phi by dt, change in flux with time. That's why this is known as displacement current, and this displacement current takes place between the two capacitors which I shows you initially. This is so between this will happens this displacement current takes place between the two capacitors. I am showing you here these two capacitors. When you put a magnetic needle here, then you get the variation in the electric field, and that's why you obtain the current, and such type of current between the two plates is known as displacement current. Some important point here to be marked. Point number one, the conduction current which is IC, and the displacement current which is ID. Conduction current passes through the wire, and the displacement current between the plates of two capacitors are individually discontinuous, but two currents together possesses the property of continuity through any closed circuit. That means you can see in that diagram, that is IC plus ID combined together and complete the circuit gives the total current I. Second point is the displacement current is precisely equal to the conduction current when the two are present in different part of the circuit. The third point is the displacement current arises due to rate of change of electric flux, which is d phi by dt, between the two plates of the capacitor. And your fourth point is, just as the conduction current is, the displacement current is also the source of magnetic field. As you know that the conduction current produces magnetic field due to charges in motion, and whereas the displacement current produces magnetic field due to the time rate of change of electric field. Hence it is clear that it means in a space between the plate of the capacitor, both the electric and magnetic field exist there, and the time varying electric field between the plates of capacitor is directed perpendicular to the plane of the plate, and the time varying magnetic field produced by the electric field is along the perimeter of the circle in a plane parallel to the plate of the capacitor. Now I am going to write the equation of electric field and the magnetic field. Equation of electric field is E equal to E naught sine omega t minus x by c, and equation of magnetic field B equal to B naught sine omega t minus x by c. These two are perpendicular, mutually perpendicular time varying electric and magnetic field. Now we can easily define the displacement current, which is the line integral of magnetic field for any closed path depends only on the sum of steady current piercing a surface bounded by the closed path. Now it is completely clear what is conduction current and what is displacement current, but I am again revising this part. The conduction current, I am writing the definition of conduction current. It is the current which arises due to flow of electrons through the conducting wires in an electric circuit. And about displacement current, it is the current which arises due to change of electric flux represented as phi E in some part of electric current. Depends on the situation, which type of circuit you have taken, and the formula of this one is ID equal to epsilon naught d phi E by dt, which I discussed with you already. Now let us discuss the important topic of this chapter, which is contradiction of Ampere's circuital law. I have taken two capacitors A and B. There is capacitor A, there is capacitor B, and having charges Q and minus Q. In fact, if Q and these charges are instantaneous value of charge on the capacitor, the instantaneous value of the current in the conducting wire, according to it, the I equal to dq by dt. Here instantaneous value of current in the connecting wire, I am right here. Here instantaneous value of current in the connecting wire is I, and this I is equal to dq by dt. And let us consider there is two surfaces, surfaces S1, you can see here surface S1 and surface S2. This is surface S2 and this enclosed part is surface S1, bonded by closed path inside the capacitor. The surface S2, I am writing here, the surface S2 is pierced by current I. Because there is I current which is flowing through this part. So current I. The surface S1 is, however, the surface S1 is not pierced by this current. This is S1 and there is no current between these two parts. So we can write here not pierced by this current because this surface is in the space between the plates of the capacitor. Yes, like this. And therefore for surface S2 you can write like this. S2, for surface S2 I am writing here for surface S2, you can write the Ampere circuital law B dot dl, which is equal to mu naught I, because I current is passing through that part. And for surface S1 is B dot dl, but you know well there is no current passes through this part because it is a space between the two capacitor, and therefore there is no current. So you can write, if there is no current, you can multiply mu naught times of 0, which is equal to 0. Thus there is an apparent contradiction is applying Ampere circuital law in this case, because there is a one current but there is no current between the two plates. Then how can you get the other side? How can you get the current on the other side of the second plate? As you know well, the contradiction of Ampere circuital law, but Maxwell modifications are applied there and applied to above situation, which I have seen already. In above situation consists of considering mathematical equivalent current to pairs of surface S1. If I am going to write here, if E is the electric field in the region between the plates of the capacitor, then you know E equal to sigma by epsilon naught, the formula of electric field when between the two plates, when one is positive and same of negative charge. Sigma, you can write sigma equal to Q by A, which is surface charge density, upon epsilon naught, and it becomes Q upon A epsilon naught. You can write the value of Q, which is equal to epsilon naught E A from this portion, and you know well, flux, electric flux is equal to E into A, and from the instantaneous current in the circuit, I equal to dq by dt. Put the value of Q here. Epsilon naught is constant. Keep it separately, epsilon naught. Yes. And this one is d phi, because E into A in form of phi. D phi, which is electric field. D phi in short, you are writing here E upon dt. The right side of this equation, this is the equation, next equation, contains the derivatives of electric flux piercing S1, while I is the current piercing S2. Yes, I am going to repeat it once again. Distinguish between I and ID. I is called the conduction current or real current or true current. All the name are same. Now, definition of electromagnetic waves. The electric and magnetic field varying in space and time and propagation through space such that two fields are perpendicular to each other to the direction of propagation constitute EM waves. Properties of EM waves, that is electromagnetic waves. EM waves propagate in the form of varying electric and magnetic fields such that the two fields, yes, it must be perpendicular to each other and also to the direction of propagation of the wave. In other words, EM waves are transverse in nature. This is a property of EM waves. Second property of EM waves is EM waves are produced by accelerating charges. Property number 3, EM waves do not require any material medium for their propagation. If there is no medium, EM waves can able to propagate without any medium. There will be also. In fourth property, in free space, EM waves travels with velocity c equal to 1 upon under root mu naught epsilon naught, which is equal to the speed of light. But in any material medium, velocity of EM waves is v equal to 1 upon mu under root mu epsilon naught, where mu and epsilon naught, mu is the absolute permeability and yes, absolute permittivity is epsilon. Property number 5, EM waves obey the principle of superposition. Property number 6, as the waves spread outwards into the free space, the amplitudes of electric and magnetic fields, which is E and B, decreases steadily. Further, you will study further, E and B in empty space are related by the speed of light, which is the relation C equal to E upon B, ratio of E to the B. Point 7, the energy in EM waves is divided equally between the electric and the magnetic field vectors. And the property number 8 is the electric vector is responsible for the optical effects due to the EM waves. For this reason, only for this reason, yes, electric vector is called light vector. Why electric vector is called light vector? Due to only this reason, because it is responsible for optical effect.